Hey grade 10s. All right, welcome to Unit 8, our last unit. So awesome. So, in this unit we're going to be looking at when we have more than one equation. And of course it's going to be a linear equation, as I've noted here, because that's what we've been studying this year. And we're going to look at when we have more than one of them and how we can use all of those equations to solve for the variables. So, let's just start right off here with the first lesson. Okay, and we're going to talk about systems of linear equations and how to develop them. So, first thing to note is during this unit, I've just put our blanks in the notes typed up because it's way too hard for me to write with this stylus. So this is just going to be there for you filled in already to copy off of. So at any point, pause the video and then copy them in and then keep going when you want. Even though I know yours have blanks, mine doesn't, is what I'm trying to tell you. Okay? So if you have any questions about that, just message me, of course. All right, so let's take a look here. We are going to look at several methods of how to solve a system of equations, but before we do that, we want to know what the heck are we even talking about, what's a system of equations, and what do they look like. So a system here is defined as a group of two or more equations, and they usually will have the same variable or variables. And we are primarily going to look at them when they have two variables, although we will have a short lesson at the end looking at when there are three variables. Okay, but we are going to focus on two variables. And when we have a system, so again, that's a group of two or more equations, we can call that system of linear equations just a linear system. Okay, that's just an easier term, and I'll often just refer to it as the system, whatever system we're looking at in that example. So before we do any of the solving methods, which I've listed here, which are by graphing, and then by two algebraic methods called substitution and elimination, which we'll look at in this unit, we are going to first look at what does it mean to have a solution to the system. Okay, so here's that definition. And a solution to a system is a set of points, x, y, where x, y solves each of the equations in the system. So I'm not going to talk too much about that. I'm just going to show you. I think that'll make more sense. Okay, so if you take a look at the first example here, we want to figure out whether 3, 2, that's a point, right, x, y. So we can, if you want, make that notation up there. You want to see if that xy point, 3, negative 2, is a solution to the system. So again, to reiterate, what is a solution? It means that this point that I've given you will make each of these equations true. So what we're going to do is we're going to plug in to each equation, in the system, and then we're going to figure out if it works in each equation. And for it to work means that it'll make a statement that makes sense. So let's plug in the x and y values here. So the y value of the point is negative 2. The x value of the point is positive 3. And I'm just plugging them in to the equation. I'm actually going to change their color so you can see what I'm doing. Okay, so just hold on 2 seconds. There we go. So I'm just plugging those x and y values into the equation instead of x and y so that we have actual numbers. Okay, and then I'm going to just work it through on the left-hand side and the right-hand side to see if I get a statement that makes sense. So if I have negative 2, and that doesn't have anything to get simplified, so I'm just going to leave it as negative 2 on the left-hand side. And then on the right-hand side, I have that 3 minus 5, and that actually also does equal negative 2, right? And so you can see that the left-hand side and the right-hand side are equal to each other. And so that makes a statement that makes sense. That's what I was referring to earlier. So negative 2 equals negative 2. That's true, right? If I had something else, if I had negative 2 equals 7, that doesn't make any sense, right? Because that can't be possible. And so we're looking for something that does make sense when we plug in. And in this first point, we've achieved that. Then our second equation has 2x plus 3y is equal to 0. And again, we're just going to see if that works out when we plug the point in. So our x value in the point is 3, and our y value is negative 2. So I'm just going to plug those in. Oops, there we go. And then solve what I have. Okay, so again, I'm just going to simplify the left side, I'm going to simplify the right side, and we're going to see if they make sense. So in the first equation, the left-hand side was just negative 2, so we left it. And now in the right-hand side, it's just 0 in the second equation, so we're just going to leave it, right? 0 doesn't have anything to change or be simplified with, so it just stays 0 on the right-hand side. And then, pardon me, on the left-hand side, we have 2 times 3 is 6, and 3 times negative 2 is negative 6. And when you add 6 and negative 6 together, it equals 0. So again, that is a statement that makes sense, right? 0 is equal to 0. And again, if I had come up with something like 0 is equal to 4, that makes no sense at all. So that would not make any sense and would not make a solution. Okay, and so we can conclude that yes, the point 3, negative 2 is a solution. Okay, so before I move on to the next example, I just want to make a statement to summarize what I did here. Okay, I know that some people can find this confusing the first time we do this, and that's okay. So here's a summary. So listen up. If you're not listening, now's the time. Just like in class, you know how it goes. So if I have a point, in this case, 3, negative 2, in the next example, it's going to be negative 1, 6, and so on, whatever, any point. And then I also have a system, like here, so more than one equation in 2 variables. Then I want to see if that point that I gave you, so in this case, 3, negative 2, when it's plugged into the system, if it creates statements that make sense. And so in this case, it did, right? Negative 2 is equal to negative 2 and 0 is equal to 0, so that's good. And if that happens for both equations, okay, both of these, not just one, then the point is a solution. We're also going to look at when this doesn't work out, and then that might make more sense as well if you're not sure how it couldn't be a solution. But to summarize, when it's a solution, it means that the plugged in point makes statements that make sense. Okay, so let's try the next one. Determine whether the point negative 1, 6 is a solution to the system. So, okay, we're going to do the same thing. We're going to start by using this point. We're going to plug into each of these equations. Okay, so we are going to start with 4x plus y is equal to 2. Okay, and so again, I'm just going to be plugging in my values of x and y, which are here, negative 1 and 6. So x is negative 1 and y is 6. Okay, and then I'm going to just work through, oh dear, there we go, the equation to see if it works out. Now, something you might have noticed is that when I'm working through this equation, I'm not moving things across the equal sign, okay? And if you notice that, I'm glad that you did, because we are never going to do that, okay? So it's like you're going to imagine there's an invisible wall here down the equal signs, okay? So you're only ever going to work with the left side on its own or the right side on its own, because as you're going to notice, once you plug in numbers like we did here or in any of the previous ones, so here or here, we no longer have any variables left over, so it's not really an algebra equation anymore. So we're not going to be like moving things around like we do with algebra. Okay, so you're just going to solve the left hand side, and then you're going to solve the right hand side, and then you're going to see if it makes sense or not. All right, so again here, once I plugged in x and y, I got negative 4 plus 6, which simplifies, of course, to 2. And 2 is equal to 2. That is true, so we're good to go there. Now, a quick thing about notation. This is just me showing myself that I checked that this makes sense. You don't have to write that check mark, okay, with the little circle around it. Like, not mandatory at all. If you just stopped, like, right here, 2 equals 2, that's good enough, okay? All right, let's do the second one. So now we have 2x plus y is equal to 3. And again, I'm just going to plug those x and y values in, that negative 1 and the 6. And we're going to see if it makes sense when we simplify both sides of the equation. Okay, so 4 times, oh dear, I made a little writing error there. Let's just fix that up. There we go. 2 times negative 1 is 2 plus 6 is equal to 3. And when we add negative 2 and 6, we're actually going to get 4, right, is equal to 3. Now, this is the first example of a statement that doesn't make sense, right? Is 4 equal to 3? No, it is not. So, no, negative 1, 6 is not a solution. I forgot to mention that this is my abbreviation for solution. Okay, so feel free to use it. I don't know if we've used that or not this year, but in case we haven't, there you go. And so the reason I'm saying that no, the point negative 1, 6 is not a solution is because while it did make this equation true, it did not make this equation true. And so if we refer back to our definition here, that a solution to a system is a point, xy, when xy is the solution to all, there's the key word, okay, all of the equations in the system. And because in this case, the point was only a solution to the first equation and not to the second equation, then we cannot state that negative 1, 6 is a solution. Okay? All right. And then let's take a look here. Determine whether the point 3, 1 is a solution to the system below. So again, same thing. We're just going to plug some points in. Okay? So y is equal to 3x minus 7. And we're going to plug in that point 3, 1. I'm going to stop changing colors because it takes too long, to be totally honest with you. So I hope that's okay. Okay, so we plugged in y is 1 and x is 3. And when I look at the left-hand side, there's nothing to simplify, so I'm going to leave it. And then I'm going to work on the right-hand side. So 9 minus 7. There we go. And 1 equals 2. Okay, that's false, right? 1 is not equal to 2. Of course, 1 is only equal to 1 and 2 is only equal to 2. And so because of that, we can already say that 3, 1 is not a solution. Now, the reason that I can just stop solving the question here and just say, this is a solution. It's not a solution, is because we already can see that it didn't work for this equation, so it doesn't matter whether it works for this equation or not. The point has to work for both, and it did not in this case, therefore not a solution.